So welcome everyone to the July 2020 Australia and New Zealand PowerShell user group. You can find us in a bunch of places online, but the main link to visit is probably that the GitHub IO, ANZPSUG.github.io, because from there you can link off to all of our social media stuff, our YouTube channel, Meetup. And we try and keep an up-to-date list of meetings that are coming up. I've got a slide in here for August, but I haven't added it to the site yet, so that'll be there soon. There are 3 of us running this group. So I'm Josh King down here in New Zealand, and over in Australia, I'm joined by Adam and Shah,
Howdy.
who I believe are both online today.
How's it going?
Hey, Adam. I saw Shah join. Yeah, there he is.
All good.
Cool. So if you feel like speaking or want to request or suggest content, anything like that, ping any of us or the main ANZ group. Yeah, get in touch. Keep losing focus. I do like to plug the PowerShell conference book. Volume 3 is being worked on now, but you can still purchase volumes 1 and 2. They are volumes. Each volume is completely new content, so it's not just updated between them. And the royalties, I guess, from each go to the DevOps Collective on-road scholarship, which is a really good, what's the word I'm looking for? It's escaping me. A really good cause. It helps get younger folk into the IT ops field, and especially those from underrepresented fields, underrepresented groups. I mentioned August, so next month we're joined by Sarah Lean, who's talking about her journey from being a traditional engineer to the DevOps world. But this month we're joined by Thomas, who it must be about 3 AM for now, who's going to school us on a bit of Regex. So, over to you, Thomas.
Yes, ready? And you're right, it is 3:12 AM, so I'm definitely at my brightest and bushy tailsest, ready to go.
As you're kicking in, how do you want questions handled? Do you mind interruptions, or do you want?
Yeah, I don't mind interruptions, but you might get your question answered, and it goes a little quick. So
I remember your 101 being similar.
So yeah, I'd encourage you to try to hold it for like a couple slides, and then if you can't, then pop it in the chat or something. I should be able to see the chat while I do this. So, ready for me to share up?
Go for it.
Just making sure. There, I got the chat. And y'all can see?
Yes, indeed.
Right on. All right. Well, thank you and welcome to Regex for Rockstars. Get my window focused. There we go. I'm Thomas Rayner. I've got a CISSP certification, which isn't going to have any relevance here. And I'm a senior security service engineer at Microsoft, which also doesn't have a ton of relevance here other than it means that I'm based out of Redmond in the Pacific time zone. So I don't normally get to interact with all you folks kind of on a in-person, quasi-in-person basis like this. So it's kind of a treat to be able to be in front of the user group and be exposed to some folks you might not normally be exposed to. I don't know when the last time you guys had a Canadian present. So you can find me pretty much anywhere online at Mr. Thomas Rayner. And there's a blog and GitHub and Pluralsight stuff here. But the PowerShell Discord and Slack, it's bridged, it's one network, is a wonderful community full of very bright individuals who are very generous with their time and their knowledge. And many of you have probably heard of it before. But if you haven't, I'd encourage you to come check it out. It's very casual and social, but it's also got some well-organized channels for support on a variety of different PowerShell-related topics. So there's a aka.ms/ps Discord or PS Slack, depending which client you prefer. And yeah, I've kind of just always been shouting that out in my sessions lately because I think it's a really great community. So this Regex for Rockstars session is a sequel to a session that I gave twice last year, but was recorded once for the ANZPSUG called Regex for Noobs. It's available on YouTube. I'm going to cover all of the same content that presentation covered, but I'm going to do it in a lot less time to make room for some more advanced concepts as well. So where the Regex for Noobs session kind of goes from I have no idea, haven't seen it before, to I can be kind of minimally functional in Regex, this is kind of a working assumption that you've at least seen it before, and that some of what you would get in the Noob session would be review, because we're going to review it more quickly and then talk about some more interesting things. So just so you know, if you're seeing some of this stuff in the first kind of recap section, you're going, wow, this is over my head, and you want something that's a little more deliberate and spend some more time on it, you might check this recording out as well. You can see it's 50 minutes, so it's not going to crush you, but it spends a lot more time on things that we'll go through relatively quickly today. So first, like, what's Regex, right? Like, let's do a little level setting. It's short for regular expression. Okay, great, moving on. No, what's a regular expression? It's a sequence of characters that defines a search pattern. So all that we're doing is kind of abstracting a real string into different wildcards and tokens. Is really just used for finding or replacing items that are in strings. This is all string manipulation. When you think of like all the different data that a computer can handle, like binary data or like an Active Directory object, etc., anytime that a computer is representing that data to a human, it's doing it in the form of a string, like, or it's like text to speech or something, but usually it's a string, right? It has to show all these complicated objects as strings, and so Regex is a powerful way of manipulating and working with strings. It's very necessary for you to learn. It's super handy for extracting stuff from log files, validating user input, replacing parts of a string, and doing data manipulation, and like tons of examples. You'll find reasons to use it the more that you learn it. Personally, I put off learning Regex forever because it was terse and it was hard to understand, and I hated it because I felt like, oh, I'm so bad at it. It's so hard to figure out. I'm never going to need this. And then eventually, if you're like me, you find yourself in a spot where you have to learn it, or you have to at least dabble. And all that putting it off you did is coming back to bite you now. And you kind of break the seal, you open the floodgates, and you start seeing all of these applications for it, and all these things that you did in a really hard way that you could have done in a more convenient way. So you all obviously know that because you're here listening and learning about Regex, and you've made the commitment, and you've probably even bumped into it because you're in the Rockstars session. So guess what? You're well. But just for anyone listening, like, it's a powerful tool. You should learn it, and let's get after it. And like I said, like, you're probably already doing this in PowerShell, especially. Like, if you've seen lines of code like this before, where this is just an array of strings and then piped into where object, and where that object matches a pattern of some kind, right? Some type of expression. And this returns these two items because this on the right side of the match operator is a regular expression. It's the literal characters SOMETHING, and that pattern is found in this one and this one, and where object is filtering out the ones where this clause is true, right? Like you've already done this. You're already a rock star. Boolean matching, where you just have a string on one side and a regular expression on the other, just returns a true or false, right? I'm covering these, obviously. We're going to use this type of syntax in a bunch of examples coming up. So I want to make sure everyone knows that the match operator takes a string on the left side and a regular expression on the right side. And they're written very similarly, if that was a straight quote. And so they both look like strings, but regular expression, string, and then a Boolean for if the string contains the regular expression, right? And this one does. This one doesn't, because this regular expression of pickles is not found in the string. You've probably done something like this before, finding the username that matches this pattern, or finding the line in the log file that starts with such and such failed to initialize or whatever, right? Like this is relatively familiar to most PowerShell users. Or doing replacements. Like here's an example. It spans over multiple lines, but this is just one line of code. Here's a simple string, and we're replacing the content at this regular expression, simple string, with a new value. And you end up getting, here's a string that got something replaced, because here's our regular expression. And the replace operator takes two arguments, takes the regex, and it takes the string to replace the value found. And so that's what you get, right? So quantifiers. Quantifiers allow you to save a little time and space in your regular expressions. And there's three of them that we're going to cover. The star character is a quantifier that tells you that I want 0 or more of the thing that comes before the quantifier, before the star character. So in this regular expression, we end up with this S and 0 or more of them, and then the rest of something.txt. And in the string that we're searching, we've got 0 or more S's here. Like I've kind of just highlighted this space purple here, but there's nothing actually there. Just for illustrative purposes, you'll see that a few times here. And then this blue part kind of matches the rest of this blue part, right? So that returns true, because this S means 0 or more. And there is 0 or more S's right there, right? Star character. So we found this whole pattern matches this value here. The plus sign is another operator, and it means 1 or more. So a lot like star, but where star allowed you to have 0, this requires there to be at least 1 of the thing that that precedes it, right? And so we have, like, the blue part matches, right? That didn't change, but we don't have this 0 or more, or sorry, 1 or more S's at the beginning of it. So this pattern isn't found. So we get returns false. There's no partial matches being returned here, right? Like this is an all or nothing thing. You either found this entire pattern or you didn't. And that's why we're getting false back. And so, yeah, there is not 1 or more S, and then the rest of the string. Question mark is the third quantifier, and it's 0 or 1, which in this situation works a lot like the star, where it's 0 or more. But when you start using the other applications for regex, it gets a little bit more important to know that this exists. But these are our three quantifiers that tell you how much of the thing that comes right before them you're looking for. 0 or more, 1 or more, 0 or 1 things. And so just for kind of a check-in with the crew, this was 3 examples for quantifiers. The regex for noob session has 9 or 10 examples. It has like 3 for star and 3 for plus and 3 for question mark, and they're explained in more detail. So if you're going, wow, this is already over my head, you might check that session out. But hopefully everyone's hanging in there and has kind of seen some of this before and is following the explanation. So I'm not seeing any questions or anything like that. So we'll keep it cooking. Right. Oh, and I broke this one down. Great. Guess there was 0 or 1 there. Everyone got that. Special symbols. So yeah, this is where things start looking a little weird. Like most people can kind of wrap their head around quantifiers. You've seen the star character in like wildcard searches and stuff, in like Windows Explorer or whatever. And this is where things begin to look a little terse. And so here's kind of a cheat sheet. This is not all of the special symbols, but in regular expressions, we're kind of representing the pattern that a string might look like, rather than the exact value that a string has, right? Like if we want to look for, like if we're validating an IP address, we might look for any 3 numbers and then a period, then any 3 numbers and a period, 3 numbers period, then 3 numbers, right? Or like 1 to 3 numbers kind of thing. We don't care what those numbers are. We just care that they're numbers, so to speak. So we're kind of creating those patterns of classes of character. So that this is some of the classes of character that we're concerned with. The start of a line represented by this is called a caret. And then the end of the line with a dollar symbol. The period is a little bit tough to see. You might mistake it for that bullet. And some inexplicable white space matches any single character at all. Like any character, like any character by the period. And then patterns you see a lot, lowercase letter, like the S stands for any white space character. And then there's an uppercase inverse of a lot of these, where like the lowercase s is any white space, then the uppercase s is any non-white space. Then we have digits, which is just numbers, word characters, which are letters, numbers, or underscores, and then like word boundaries, which there's a handful of as well.
Question.
Yes.
Letters and numbers, do those include non-ASCII letters and numbers?
They're supposed to, but there's so many of them that it gets a little bit complicated. Like there's also like one of the things that sometimes get matched or don't are like emojis and stuff like that. So there's not a one-size-fits-all answer for that. I don't think it's binary, and to be honest, I haven't dabbled with non-ASCII characters enough to really give you a confident answer on that one. But it's a good question.
Oh, thanks.
So we'll blast through a couple examples of these, and just to kind of again refresh. Here's a regular expression. You'd look at this and go, like, okay, this is the input string. And here's the regular expression. If this was a literal period, like sum and then a period and then HING, this would be false, right? But it returns true because we have our literal characters, SOME, and then the period special, right? You guys remember the period means any character at all, HING. So this is found because we have these characters, then any character at all does exist there, and then the rest of it's right there. Returns true. Found our pattern. The digit symbol \D together is 1 token, right? The / is the escape character in regular expressions, and it manipulates whatever comes after it. So this is 3 numbers, and then we're looking for a number character. So of course this returns true, right? We found it. Boom, there's a number right there, 123. But just to be complete here, this is a match, that's a match, and this is a match. Like there's 3 different digits in here that are being matched and true. So yes, this is true, but there are 3 different matches in this one string that's being input here. So you have to just kind of be aware of that and know that that's occurring when you're building your expressions. And like if you wanted to work with the value that got matched, then you might be surprised if it didn't look exactly like you thought it should. Here's another one. This is just, again, showing that the capital D is any non-digit, and all this has is digits, so we didn't find that pattern anywhere in there. So this one returns false, right? The word characters are letters, numbers, and underscores. So, of of course, that returns true. And of course, just like with the digits, we have 8 different matches in this string, right? Each one of these is a word character. So this returns true. And then kind of a weird concept to illustrate is the concept of a zero width match. We kind of tried to show it in the quantifier section for the star, but this breaks down to the start of a string, right? That's the caret. Then the literal characters H and I, and then the end of the string, highlighted in yellow, is the dollar sign. And so again, just to not belabor the point, but where I've done this in the input string to kind of highlight how this lines up, this blue area here is not like a space or anything. This is a zero width thing that I just had to represent to you somehow. Same with the end of the line. Like when you get your value returned, like if you were working with this value as the match rather than just whether it was true or false, if it exists, you get the characters that are there, but there's no white space or anything that you need to trim. I'm just representing it like this so you kind of know how this lines up. I hope that's clear for everyone. This is kind of how it all goes. This pattern of start of the string, HI, end of the string, is matched here where the string begins, you have your letters, and then the string ends. Clear? Here's a fun one, right? Like if you're new, this could really trip you up. The pattern we're looking for, \slash, right? And I've got right here, boom, \slash. But okay, found it, great. Wait, oh, false. Why is that false? Hold up, I can see it with my eyes in my own face that this is right there. Because remember, these are kind of parsed sequentially, right? The first is a \. Oh, okay, that's the escape character in regex. And then what does it do? It manipulates whatever comes after it, which is this S. And what's \s? Well, that is the token for a white space character. And then LASH. Now, the way regex searches through strings, this match is of no consequence whatsoever, because first it's going to look for a space, and it's not going to find one at all, and so it's just going to say, no, I didn't find it. It would have to find that first and then find the rest of your string. But just for illustrative purposes, like, yeah, okay, we have this part, but this doesn't exist, right? And so the thing that comes before this is an S character, not a space character. So if that's not found, right? That regular expression is not found in this string. If I wanted to search for the \, and then the word slash, I have to escape the escape character, which is a super weird thing to think about sometimes, but kind of a necessary example I find to illustrate. Of course, there's a truck right outside at 3:33 in the morning. Yeah, so this is found because this is a \, a literal \, not the escape character, and then the word slash, which is perhaps confusing. But there's my \, and there's my word slash, and that pattern is found. This whole thing is found right there. All right. So that's just kind of a crash course. There's lots more special symbols, right? Like again, we didn't talk about the A and the Z. We didn't really talk about word boundaries and what that means. And then there's more of these, right? Like these aren't the only special characters, but I think that it covers all the special characters we're going to use in the rest of this presentation. So you're at least armed and ready for that. And what you're definitely got now is a strong grip on the fact that these are tokens. Let's try that. Did you guys already see this the second time, or were we kind of just right here?
Yeah, it'd come up the second time.
It had? Okay,
Yeah.
Wonderful. So I don't have to belabor the point of what escaping backslashes means. All right. Okay. That didn't totally disrupt any kind of groove we were on, did it? And so, yeah, I don't know how much of this one you caught, but just to reiterate, because that was super flow breaking, there's lots more special characters than just what you see here. And there's the lowercase, uppercase pattern that these tend to follow, where like it's an affirmative and then a negative match of whatever they are. They're kind of easy to correlate. We didn't talk about all of them, like the A and the Z we didn't talk about. Is Z Canadian? Yes. Well, I'm on your side. But I think we've got everything covered in terms of special characters that we're going to see for the rest of this presentation. So we should be all right there. Any questions before we go until we go forward? Any questions about special characters? No? Yes? Everyone's got it? Perfect. So let's talk about brackets, round brackets, square brackets, curly brackets. This is another one that has like 10 or 12 examples for noobs, but we've got 3 for you rock stars. So we got time for more stuff. Curly braces first act like a custom quantifier, which is fun to say because it's an alliteration. And so it, in the curly brackets, is the quantity of what comes before it. Just like the star was 0 or more of what comes before it, and the plus was 1 or more of what comes before it. In this case, we're saying, this is true by the way, is we're looking for 3 of what comes before it. And now you can also put a comma in here and another number to make this between 3 and 6 of something. Or you can just do comma and then a number and get, or like 3 and then a comma and then nothing. And then that's at least 3 somethings, whatever comes before it, right? Custom quantifier. So in this case, this isn't 3 individual matches, right? This isn't a 1 and a 2 and a 3. This is a digit and 3 of them. And so this is 1, 2, 3 is the entire match there. Okay? Different than the example we saw before with the 1, 2, 3 and the \D. So we found it. Good. Round brackets. We're going to talk a lot more about round brackets this time. But for now, they create a group. They almost kind of work like they work in algebra, where you sort of create this association of elements together. And I want to treat everything in here as one entity. We'll get into some more examples. So this one, again, returns true. Our super obvious string here. Let's break it down. We have the hello 1, 2, 3, and then we wrapped it in round brackets and applied a quantifier to it. Is basically how you can read this. So we know what this is. This is a custom quantifier for we want whatever comes before it twice. Well, what comes before it? Well, the end of our group. What's encapsulated in our group is hello 1, 2, 3. Here's the beginning of our group, the content of our group, the end of our group, and then something that addresses the group. I'm going to say the word group about 10 billion more times. So hopefully that doesn't trigger anyone. So we've got our first hello 1, 2, 3. Then we've got our second hello 1, 2, 3, and that is our 2 hello 1, 2, 3s. So that's true. Yes. Found it. That's the whole match. Like this entire thing is matched by this pattern, by this regular expression. Now square brackets denote a set. So this one returns true, even though I don't see a square bracket, FG, H square bracket, $sign anywhere in here, right? Like this gets a little abstract. What this is saying, if we break it down, the $sign is the literal end of the string, which again, representing in the 0 width space character here. And then these square brackets are a set and saying, so it's either F or G or H in the space of one character, followed by the end of the line. And so what we have is G, which, as fate would have it, is F or G or H, and then the end of the line, right? So this string ends in that character, which is basically what we're checking for here. So if this was like something with an F and a G following it kind of thing, that would still work because we're only looking at one character before the end of the line, right? Or before the end of the string, I should say. So we found it. And again, the G is the only thing here that matches. It's the only actual string that would ever get returned here. That end of the line character is 0 width. Okay, so sets one of these things and then that. And that's brackets. The regex classing things up a little bit. So if we want to do better than just Booleans, like all the examples we've done so far are using the match operator in PowerShell. And so we've been just getting Boolean results back. It's either finding the match or it's not finding the match. And we want to do a whole bunch more interesting things with our matches. So here is an example. I'm just accessing the matches method on the regex class, right? This is hopefully familiar to people. And this method takes, it has a couple overloads, so it takes a couple of arguments. Oh, there goes the truck again. Let's see if I drop off, even though that shouldn't be related. It's taking the string that I'm searching, and then it's taking a comma, and then another argument for the regular expression that I'm searching for within this string, right? And then this returns not just a Boolean, but like an entire regex match object. And it's got groups, everything. Like this always returns a 0 group, which is the entire match. Whether or not it was successful, the name, captures index value. Oh, value. That's cool. We actually got the characters that are in here that are regular expression matched. So let's break it down. I'm not sure what that changed with, but we're looking for a word character, right? One or more of them, and then the end of the line. And so we found a word character, one or more of them, and then the end of the string, I should say, in our 0 width area here. And found it, and that value was part of the regex object, or the regex match object that was returned. So we can do a whole lot more with this than we could with just the Boolean matching that we were doing with dash match, right? We can do things like access the dot value property and just get our username out of this. So you can kind of start to see, like, it's great to see if something matches a pattern or not, but when it does, sometimes, like, you're searching the log file for this service crashed. Well, which service? I want this name of the service, right? So I need to actually be able to extract those values and work with them. There's lots more in this regex class. Like, we were just using the matches method, but there's also confusingly a match method. The difference between which will the matches will give you all the instances of the matches in your string of your pattern, where match will stop after the first one. There's a replace, and there's more. There's a whole bunch of cool stuff you can do. You can also just create a regex object and then make it perform those matches for you, which we won't really get into because I guess those are Rock Legend features, not Rockstar features. And also because I want to respect your time. So that's the recap. That's everything that was covered in that regex for noobs session. So if you flew through that and you're like, yeah, right there with you, good to go, time to up the game a little bit here. If you're sitting there going, holy crap, I just got blasted by the fire hose, hang in there, because it's not that much worse. But you might want to go watch the For Noob session afterwards and just kind of up your knowledge there. I don't do a lot of sequels, so hopefully this is working. Okay, so the first Rockstar thing you got to do with regex is parse HTML. No, don't ever try to parse HTML with regex. Okay, like, you can do a lot with regex, and you go, well, HTML is just a string. I could totally just, like, oh, no, don't. Like, I know what you're thinking. He's like, oh, sure, but maybe one. No, there's no, don't do it. No, don't do it. And I mean, like, okay, if you're just trying to like get the value from a link or something, it's a simple page. Maybe you can do a little bit, but no, don't ever. If I see, like, this is the one thing that I won't help you with. Like, if you get stuck with your regex and you're trying to like figure out how to make it work, and you find me in the PowerShell Discord or Slack, I love helping people with regex because I find it really fun. If I find out you're trying to parse HTML, I will stop helping you because it's there's a better way. There's always a better way. Point delivered? Okay. But let's talk about grouping. So this is like more round brackets. +1 to guys, question above. What about the matches hash table after using match? We'll get there. Don't worry. Actually, we'll get there pretty presently if memory serves correctly. Grouping is going to rely a lot on round brackets, and well, you'll see why. Okay, so not quite yet on Guy's question, but we'll get there. I promise it's coming. Here, we're using the match method on the regex class. And also, I just realized my syntax highlighting went away. Okay, whatever. I'm matching this in this string Bond, James Bond. I'm looking for James and then a \s and then Bond, right? This is James, a space character, and Bond. And we found it. Great. And we would get this type of object back where the value that gets returned is James Bond. Okay, super. But like, what if, and like this could have just been like word character space word character, right? Like with quantifiers and stuff to just capture this properly. But I'm just kind of keeping it simple for this illustration so you can tell where it's coming from. What if I wanted something more intelligent? Like, what if I wanted to know the first name and the last name out of this? And instead of like James Bond, it was like \W plus \S W plus kind of thing, right? And that would still match this, but it doesn't break it down into its components. Enter grouping. And so here, like, this begins to look a little more terse, right? I've got a pattern, which we'll come back to in a second here. And like bad variable names, it's PowerPoint. You'll have to forgive me. And then in the mat variable, I'm storing the output of, here's my input string again, the exact same thing. And then the pattern I'm looking for is this one above. Like, this one can fit on one line in any way that was reasonable. So variables. And then so if we kind of break this down, like, this isn't how the regular expression is parsed, but this is how a human might look at it. You've got your James, you got your James, you got your Bond, and you got your Bond, and then you got like your white space character and your white space character. So you kind of see where this is going, right? Like, okay, I can kind of tell what this is going to do. And then, like, okay, I've got round brackets encapsulating some stuff here, right? So I'm creating groups, grouping section, kind of makes sense. And then I've got like this part that I'm not entirely clear on, this kind of olive tan part. Anytime in a regular expression group that the first thing that you see in there is a question mark, it means that there's some kind of instruction coming. Like, I'm sure there's exceptions to that, but as a rule of thumb, if you get a question mark and then something that follows it, this is an instruction to the regex parsing engine and not part of the match itself. And in this case, we're creating named capturing groups. That's the first type of group we're looking at here. So I'm matching this value James, and the value is going to be called. I'm grouping this match with the name first, and then I've just got this S hanging out there naked, and then I've got another capturing group here that's named last. And so let's look at what you end up with. And so this whole thing matches the exact same text as before. But what we've done basically is inject metadata into what the regex parsing engine is going to return us. So when we run this, the value that's stored in this variable is another regex match. And so again, you kind of get, let's go back one. You have your value, just like you had before, and a lot of this looks pretty similar. But as we look in the group section, like we had this 0, you always have this 0, which is just the entire match. But then I also have a group for first and a group for last. And that kind of lines up with my first and my last named capturing groups, right? And so if I look at mat.groups, I get my first one, which is kind of a cyclical reference to itself. Like it's a set that contains itself, which is a little bizarre and kind of a pain in the ass. But then, and then normally this would all just be one column, but again, it's PowerPoint. Then I also get this capturing group with a name, and this other one with a name as well. So I've got my first and my last that I created here. Like this hasn't changed. And I've got my entire match, which is standard. And then I've got this group called first and this group called last. And you can see the value is different, right? Sorry. The value of the first group is James, and the value of the last group is Bond. And now I still get like my entire match, but now I have a way of isolating these things. And so if I had done this with like the /W's and stuff, then I could programmatically parse this for their name. Like maybe this is Michaels, Sean Michaels, and it's, you know, like insert a variety of different names, and I just want the name part out of it. You can kind of start to piece this together from the contrived examples that I contrived to show you into real world examples that you might have. And so I can access this like a dictionary, right? Like if I go groups and then I access the one that's named first, then I can just isolate that one and I can just retrieve the value property of that. Like, right, this had a value property. Everyone's good on that. Access the value property of the match that was first here. And I just get James back. Does that make sense? Seeing no objections. It's hard to read a room when the room is virtual, right? Like that's kind of the fun of virtual presenting is you could all be asleep or you could all be on the edge of your seats, but it's probably somewhere in between, and we're just going to keep rocking. Here's another one. So this is the first instance of the matches hash table that was asked about earlier. And so I've got the same pattern here, which is my named capturing groups. I want one named first that matches James, then one named last that matches Bond. And then instead of using the regex match method, I'm just using -match here, the PowerShell operator. So this returns true, and then I'm done, right? Well, if you didn't know, special to PowerShell is an automatic variable called $matches. The matches variable is automatically created every time you run -match. Okay, and what it contains after I did this is 3 things. I get a 0, like this aligns with what I got back here, like a group named 0, a group named first, a group named last, and this contains a group named 0, a group named first, and a group named last. A lot of people see like you access $matches and then a square bracket and a 0 and a square bracket, and they think they're accessing it like an array, like it's a running list of matches. And that's not the case. When you see people accessing the 0 item in that matches automatic dictionary that gets created, they're accessing this named group, which is just 0, which is the entire thing. You always get this, which is just this is the regex group of everything you went and done matched. And then here's my named capturing group of first and my named capturing group of last. All right, in case that wasn't clear, these names, named capturing groups are being represented here, which means you can go matches dot last, and retrieve the last name value that you got there. Okay. And so there's more you can do with this. There's more explicit things and more nuanced and detailed things that you can do with this automatic variable. But this is most of what we're going to be, the type of thing that we're going to be doing with it today. So that's named capturing groups. You can do a whole mess more stuff than just named capturing with round brackets and with working with groups in general, right? You can do things like look-aheads, and I'm so glad that ASCII art made it from one monitor to another. So, like, what the heck is a look-ahead, right? So let's, again, recap. Everything that we've done so far, all the matching that we've run through kind of works like, well, we match a character. We said it's the literal character S-O-M-E, and then a period, which means any character, but still a character, and then H-I-N-G. And then that character is part of the value that gets returned, right? Except for the caret and the $, which mean the beginning and the end of a string, right? But otherwise, that character that we include in our regular expression is part of the match, right? Like the J in James gets returned there. But what if I wanted that not to be the case? Like, what if I wanted to validate that a character is present in part of the match, but I didn't want to have that character or the pattern in general part of the actual match itself? Like, what if I wanted to validate the part of an email address or get, here's an example. I've got a string of domain/username, and I just want domain. So, like, there's ways that you can do this without a look ahead, right? Like, I could do this, where I do the start of the string, and which is a 0 width thing, kind of like a look ahead. The start of the string, word characters, and a plus. And then it's going to get me the start of the string, and then word characters. And that goes until the \, which is not a word character. So I would get that. I could do this, which is start of the string, and then characters that are not backslashes, and 0 or more of those, right? A caret inside of a set negates the set, yes. Again, that's one that we dive into on the for noob session. But here's a character that's not a \, and here's 0 or more of them, kind of representing the quantifier that way. And then, oh, here is a \, so that's where I'll stop. Right? So I could do any of that. I could do this named matching, where I have a named capturing group named DOM, and then word characters, and then any separator. Like maybe the separator is sometimes a slash, and sometimes it's a tilde, and sometimes it's a hyphen, and sometimes it's a space. And then I have a username that comes after it, and that's what my file looks like. And then just access the DOM named group on the match that comes out of that. But let's just say I wanted to use a look ahead. And like, I know you're still wondering, like, what's a look ahead? For the purpose of this illustration, consider this pattern. You go, okay, I've got a word character and a word character. And I've got one or more of them. Okay, but what's going on? I've got round brackets, which denote a group of some kind. And then I've got a question mark, which I know from experience of the last like 10 or 15 slides is going to give me some type of special instruction for how to handle this group. But it's not a named group. It's a look ahead. This is the syntax that tells you this matches the space between characters where the next character is this right here. \. It's a literal \. I'm escaping the escape character, which means \. And so you go, okay, great, I found the pattern. But remember, because this is a look ahead, it's a 0 width thing. And it's saying you match the space between characters where the next character is this pattern. So the next character is this pattern, but because it's a look ahead, it technically matches this invisible nothing that my highlighter is going over, my laser pointer is going over, the space between characters where the next character is a backslash. Okay, so that means that this entire thing matches just the words domain. And then it matches this space between characters where the next one's a backslash, but not also the backslash. So I might be belaboring the point a little bit here, but that's the purposes of a look ahead and a look behind, is it's matching the space between characters where there's a relevant character on the other side of that imaginary space. Okay? So again, kind of an abstract concept, and you're starting to see like, well, why would I ever want to use that? Like, you just showed me 3 other ways to get the thing that I wanted, and I could just trim out the username. Or like, I get it, I do. The beauty of Regex is also sort of the curse, which is it's enormously flexible, and often there's like a dozen different ways of solving the one problem that you wanted to tackle, right? And like, this is arguably more terse and hard to understand than like one of the first ways I showed you. But it's an important concept to know about, because you might see somebody else wrote one. Like, when I discovered what look-aheads and look-behinds were capable of, I used them everywhere. I overused them. They're not even necessarily very efficient all the time, but I just thought they were cool. And like, when all you have is a hammer, every problem looks like a nail, I kind of fell into that trap, right? But there's absolutely going to be situations where you are best served using these zero width character matches, like look aheads. Let's look at another example. Here's one. I've got user at domain.tld, top level domain, matches this pattern. And so what I'm trying to do here is just tell if this suffix, if the top level domain is top level domain, and if there's a domain that actually comes after it. So let's break it down again. Like, why is this return true? Because I've got a word character and one or more of them. I've got a word character and one or more of them. And then, right, I've got a group here and a special instruction that says this group is a look ahead. So that means that I'm matching the space between characters where I've got like whatever came before it, and then the next character is a backslash dot, which is a literal period, an escaped wildcard here, and then TLD, the literal characters here. And that's what, so like, I've got the period and I've got the TLD, so that returns true. But what actually got matched, and if I look at the value of the match, I've just got the word domain here. Make sense? Because I'm matching all those word characters, and then where what comes after is .tld. And then the value that got matched is just domain. But I've validated that it's followed by this other string of characters. If I did something like this, this one returns false. It's the exact same regular expression, but it's domain.else now, and that returns false. Because I've still got word character, one or more of them, and then what comes next? Well, a period. Got my period on TLD. Well, nuh-uh. I don't have .tld there. I've got else there. And so this doesn't match. It doesn't matter that the rest of this matches. What follows it isn't what I want to be following it. So, and to be clear, like, this isn't how regular expressions are parsed, right? Like, it doesn't look here first just because there's a period. It's going to go, I've got a word character, one or more of them, what comes next? An @ sign. Oh, well, I wanted a word character, one or more of them, and then .tld, so that doesn't work. And then it's going to go, okay, word character, one or more of them, a period, oh, we're getting close, and then not TLD, so that didn't work. And then it's still going to move on and go, a word character, one or more of them, and then like there's no dot. It's the end of the string. So I didn't find that either. And then it's going to go, I didn't find this pattern, right? So just again, to kind of reiterate, the way that I'm representing them on screen is not necessarily the way that the regular expression engine is parsing and searching through your string. But it is kind of the way you can think about it. So that's false. Look behinds are like a look ahead, but instead of looking for the character that comes next, we're looking for the character that came before. And so naturally, we put the look behind, which is this, you might predict, before whatever comes next. So let's just walk through this and see what it is. Breaking this down, word character, more of them. Again, okay, word character, more of them. And then a group. This is a look behind. So it's like a look ahead, but it's different syntax. And you go like, oh, how do I memorize this syntax? Like, what's the trick for this? It's like, I don't know. You could argue that this kind of looks like an arrow that points behind. It's not going to help you. Like, some of this you just have to memorize. There's cheat sheets that are out there. Experience is going to help a lot. And you just have to sort of recognize this. This is part of the frustration some people have with regular expressions is, like, how do I know that that's a look ahead? Like, a look ahead was just equals, but a look behind is like the angle bracket, and then it just is how it is, right? And so what am I looking for? Like, so word characters, more of them. And then prior to that, I'm looking for the literal characters USER at. So I've got my USER at, user at, and then word characters, and then a period is not a word character. It's not a letter, number, or underscore. It's a period. And my match is still just domain. Like, I've got the exact same thing here, right? Because I'm looking for the space between characters where what came before the space between characters right here is this pattern, this value, right? So I'm looking to make sure that this is there, but I'm matching the space between characters where this is there and then what comes after. Okay? Again, kind of a weird concept, but super powerful, and you can use them in all types of different situations, especially where you want to make sure that that value exists, but you don't want to work with it afterwards. That also works in like the match method on the regex class, etc. But we're just kind of using the matches hash table. And of course, there's negative look aheads and negative look behinds, which I'm proud of this. It's like if you had a look ahead or look behind, but not. Right? Like the concept, we're going to start talking about like double negatives and stuff like that here. So it's going to become a little bit of fun. But let's look at this example. I've got a variable called possible, which is a string. Like maybe this is contents in a file, maybe this is multi-line or something, but it's represented this way because it's PowerPoint again. Domain1 / Batman, comma, space, domain2 / Robin. This is one string. This is not an array. It's encapsulated in single quotes. Okay, just to be clear. Because you look at this and go, oh, it's a collection. No, one string with a comma in it. Maybe you copy and pasted it out of an email, and there's like 50 of these. And so what I want to do in this contrived example is isolate the domain where Robin isn't in it. Okay? So like what I really want is the value domain1. Like looking at this and knowing what I want the value of the domain, because I got domain1 Batman, domain2 Robin. I want the value of the domain that Robin isn't in. I don't care who is in it. In this case, it's Batman, but maybe it could have been Alfred or Catwoman or somebody. I want the value of the domain that's not Robin. Okay? And then, so we'll come back to this regular expression, but I'm using the match method here for search my string for my pattern and then look for the domain group. So just understand that's sort of what this line is going to return. And it returns a domain group with domain1 right there. So how was that possible? Huh? Possible puns. Well, I've got a named capture group. Like, let's just go through this regular expression. I've got a named capture group, named domain, which I'm accessing here and getting right here. So that's pretty straightforward. That's not actual content being matched, though. And then I want \w plus is just a string of word characters, right? So as we're looking at this, there's a string of word characters. That's a string of word characters. And another one, lucky number 4. These are all my eligible matches, like ignoring the rest of this regex. These are my eligible matches for this named capture group. But there's more regular expression. What's next? Well, backslash. So now we're matching word characters and a backslash. But those word characters that I'm matching are part of this named capture group. But this whole thing has to match for the pattern to be found in that string, right? This partial match means nothing if the whole regular expression isn't present. So backslash, okay, I've got a backslash here and a backslash there. I've got 2 eligible values. And then this is a negative look ahead, right? So I've got a group encapsulated in round brackets, and then a question mark, which kind of just denotes, hey, more information, like kind of some of the characters that come after this are not part of the matching engine, but are not part of the matched value, but are just instructions for the matching engine. And then a not equals, like an exclamation equals. This is just a negative look ahead. And what this is saying is it's the exact same as a look ahead, which would normally be where what comes next is these literal characters. But because it's a negative look ahead, it's where what comes next is not these characters, right? So I want this named capture group, named domain with word characters, then backslash, and then the space between characters where what comes next is not Robin. So Batman is not Robin, but Robin is not Robin. So this isn't a match. Whose brain is a pretzel, right? Like I told you, double negatives were coming, and human brains don't really handle double negatives very well. But does that make sense? Like named capture group for domain, then a backslash, and then a value that is not the literal characters ROBIN, which this is, so that's not eligible. This whole pattern was found right here. Word characters, a backslash, and then what comes next is not Robin. And I'm accessing the domain group here that I named, and the value is domain 1. This backslash is part of the match because it's just hanging out there. I could have put it inside of this negative look ahead, or I could have put it inside of the domain named group itself, but I didn't. Okay. And so exclamation point equals negative look ahead. And then, yeah, I'm using the name capture group. Here's a slightly simpler example. I've got input, which is 10 candies costs $5. Cost. 10 candies cost $5. Costs, whatever. I don't know if that S should be there, but Canadian, you'll have to excuse me. And then I've got a pattern that we'll come back to in a second. And then I've got regex match for the input, searching for the pattern, and then isolating the value that got matched. In this case, I want to know how many candies. Okay. And I get 10 back here. Magic. Okay, maybe we should explain what's going on, because this looks like a mess. But it, like, there's one letter in all this. The rest of it is symbols. But somehow I isolated this 10. So let's break it down. Let's look first. There's this part that's happening that makes us all sad. But then there's a backslash D plus, which is just digits, numbers, 0 to 9 plus. So we have two candidates. We have this 10 and we have this 5. Okay, well then what we know is this part must have eliminated this 5 from contention. So what is it? It's a negative look behind. So round brackets for a group, question mark for special instructions coming, and then the left angle bracket and an exclamation point is a negative look behind. And then this is what we're negative look behinding for, is the $, which we have to escape because otherwise it means the end of the line character or end of the string. And you can't really have an end of the string come before the end of the string. So what we're saying is I want numbers where what comes before it is not a $. And that is a $. So I don't want that number. I want the number where what precedes it is not a $. The numbers now peek behind it. Oh, is that a $? I don't want it. What's behind this one? Well, the beginning of the string. So this one's good. I wanted the number in here that wasn't a currency, basically. Okay? And again, how do you remember that syntax? I don't know, like it kind of looks behind with the arrow, and then exclamation point is pretty normal, like not kind of connotation in terms of programming languages. My recommendation, like I had to look up whether the exclamation point went on the left or the right of the angle bracket when I made this slide yesterday for you earlier this morning. Because I forgot. So sometimes you have to just look it up. But understanding the concept of look aheads and look behinds, negative look aheads, negative look behinds is enough. Like now you know the term to search online for. Memorizing the syntax is not that important. Knowing that the concept is there and that you can look it up and learn about it when it is actually relevant to something that you're working on, that's what's really important, okay? So again, this 5 is ineligible because what comes before it is a $, which is not a $. So there's our match. Okay? This is all just teaching you terms to Bing. I work at Microsoft, remember? Non-capturing groups. This is our last topic. I know that there's a lots of pretzel brain going on, so this one's simple. It's a simple premise, at least. In a non-capturing, so let's just say you have this happening, where your input is it costs $40, and then we'll look at this in a second, but you're matching the input to that pattern, and then let's just look at the groups that get returned. We don't care about the $40, we don't care about the $, and we just want to see what groups are returned when we do this. This returns 3 different groups. Let's break it down. We have kind of this $, literal $, backslash right here. And then we have these digits that come after it. Okay. And like in our 0 group, in 0, 1 price, you'll see. Then wrapping this in round brackets creates a group. Even though we didn't give it a name like we did to the next one, this still creates a group just by doing this. And maybe we wanted to give it a quantifier, or maybe we wanted to use this something else. Like there's a whole bunch of reasons that you might do this. Like quantifiers are the most common, but who knows, right? And its value is returned here. It just gets a name of 1. Like the overall match gets a name of 0, and then a name of 1 for the first group in here. And then I've got a named capture group that I've named price, which you see here, with a value of 40. So I've got 3 groups. I've got the group that just gets created by my match, and then this one that got created just by wrapping this in round brackets. I created a group that's just automatically named 1. And then I have my named capture group named price. See where these all come from? These are just the groups isolated here. Now, like, this is fine in this example, but what if this was particularly hellish and had like 60 different groups get returned? Or what if some of them are big and I'm running this in a place where like every byte of RAM matters, kind of thing, right? And so I don't care about this $. All I care is about the price. but for whatever reason, this was necessary to put into a group. Because maybe it's different quantifiers, right? Like, again, contrived example. I want to get rid of the $ captured group because, hey, it's my presentation and I don't like it. It's taking up too much RAM. I need that RAM for running Teams. Well, I can give that group a special instruction. Question mark for instructions for my group, and then just a colon. And all of a sudden, this is what's called a non-capturing group. This colon says, don't capture me, bro. And returns my overall match, this whole group 0, and the group for price, because none of the rest of this changed. But I don't get that bonus group of the $, right? Like, I didn't just erase the text. Like, this is all that gets returned. None of the rest of this changes. I still match my $, and then I still get a named capturing group that contains digits, and that's named price. But that automatic one that got created doesn't get returned in groups. So that can be helpful sometimes. Another thing that can be really helpful is there's been some links shared in the chat for like Rubular and stuff like that. And I like Rubular because it has a pretty cool cheat sheet. But Regex101.com has all this cool stuff. Like, it's got a quick reference down here that's searchable. It's got sometimes different languages will parse Regex a little different. You'll notice .NET's not on here, but it's pretty similar to the rest. But what I really want to highlight, so it's easy to see, is it's got this area here where you can put in an array, a collection of test strings. Like in this one, I'm putting in an IP address and then something that's not an IP address but has kind of the same elements. And then you can put in your regular expression up here. And then you get all this highlighting and an explanation of what all the different stuff in your regular expression is doing. So if you're new and you're inheriting some type of crazy regular, like, what the heck does this do off the top of your head? Well, you can break this down. You can look at this and go, it's a digit and 1 or 3 of them. And then it looks like we're validating IP addresses incorrectly because we're not taking valid ranges into account. But we're validating that it's formatted like an IP address. I can kind of get this broken down and see, okay, angle brackets 3, angle brackets, oh, that's a quantifier for what comes before it. And then this is like, I can't scroll in here, but you get the idea. This will programmatically explain your regular expression, and it'll allow you to test on the fly your regular expression against a set of test strings. So if you have like a group of domains or whatever, or a group of like OUs, represented as strings, and you want to see if your regular expression is working, then you can here. And there's plenty of sites like this. There's plenty of tools like this. I like this one for its explanation. I like Rubular for some of the cheat sheet stuff that it has going on. There's a .NET specific one. I think it's called like Regex Storm, STORM as in mother. Which does like .NET specific stuff, because trust me, you can run into some head scratchers when like Perl renders or executes it different than .NET or whatever. But tools like this are super helpful, and you should absolutely kind of look into them as you're going on your Regex journey. So thank you so much for having me. I really appreciate the opportunity to speak in front of cool groups like this. Thank you, Josh, for organizing everything, and for the other organizers for running this group. It's great to be able to connect with you folks. I hope you got a little bit more empowered to dive into Regex where maybe you weren't before. And even if some of the earlier stuff was confusing, it should feel more accessible than it did before. Maybe your takeaway from this is, I gotta watch the For Noobs one, but you should feel better about it than you did. You got this. You can do this. This is accessible, and it's super powerful and helpful in like every situation where you try to work with strings. It seems like So you can do this. If you need help, you can find me on Twitter, or you can find any number of people with more bandwidth on the PowerShell Discord and Slack. Once again, thank you for spending your time with me to learn about Regex. I know it can be scary, but again, you got this. And that's all I've got.
That was awesome. Thanks, Thomas.
My pleasure. Happy to do questions, but I want to be respectful of your time as well. I don't have Scrum for another 5 hours, so.
Well, before too many people drop off, I'm going to stop the recording because I'm going to share a link to something.